All right, boys and girls, a little more help with the ambiguous case. Okay, number 10. We've got triangle ABC. If you followed along with the videos, then you know that I put my angle that's given in my bottom left. It's just a convenient way to set these up. And then I make the side that I know the left side whenever possible. And this is what sets up the ambiguous case. Okay, so now what we need to know is what is the height or the altitude of this triangle. So we'll solve it by using sine. Sine of 57 is opposite, which is h, over hypotenuse, which is 10. Multiply both sides by 10, and you get h equals 8.39. So notice, I'm just going to call it 8.4 for now because that's all that we need to know for this problem. Okay, so it's asking what measure of AC would cause there to be two triangles. What would those triangles look like? Well, one would be an acute triangle where this was 10, this was 57, and this was 9. Spoiler alert, that's the answer. But it could also look like this. It could also, I didn't mean to. It could also be 10 here, 57 here, and 9 there. So why is 9 the answer? Well, if 6 was the answer, well, then we would have the case where the leg was bigger than the hypotenuse. So it cannot be 6. Okay? So what's wrong with 12 and 15? Well, if 12 and 15 were the answer, then since this side was bigger than this side, there couldn't be a way where we could fold this angle, this segment over. Essentially what's happening is you're hinging it, and it could also reach there. Well, that wouldn't happen with 12 because it would all end up all the way over on the other side, and this would no longer be a 57-degree angle there. So what you need to know is if the side on the right is bigger than the side on the left, then there is not an ambiguous case. There's only one solution. So that rules out that and that. So it's the 9 is the situation that creates these two possible triangles. And if you remember from geometry, this is why angle side side, ASS, does not work to prove a triangle, because there's two different triangles that satisfy that angle, that side, and therefore you can't prove triangles congruent. I hope this helps a little bit. This is probably one of the tougher little topics that you hit, but I also want you to know it's not that big of a deal. It doesn't come up a whole lot. It's just something that people get hung up on.